So hello everyone. So today we will see the properties of conjugate, modulus and argument. Okay, so let's one by one we will see. So let's talk about the conjugate. Okay, so conjugate, we know that let's say any complex number is z, is given by, let's say any complex number is uh, a plus ib, corresponding conjugate is given by a minus ib. So in conjugate you just need to replace I with the minus I. Okay, so you have to just replace I with the minus I, and then you will get the conjugate. Okay, and geometrically they are something is, let's say somewhere here is the z, so its conjugate will be minus. So basically let's say the argument of z is r and theta, so corresponding z bar or the conjugate have a argument minus theta, and the modulus remains same. So the modulus of z and conjugate remains same, whereas the argument of z is minus of argument of z bar. Okay, the argument is just reversed. Okay, so let's talk about the some of the properties of the conjugate. So let's say we have any z1 plus z2. If we take z1 plus z2 and if we take the conjugate, then the conjugate is equal to same as the separate complex number. Similarly, if we take the minus sign here, z1 minus z2, then there also be corresponding conjugate. Okay, similarly, if the product is there, z1 z2 product is there, then the conjugate is also z1 z2, they are separated. Okay, same with the addition. Let's say division, z1 z2, overall if I take conjugate, then this is conjugate of the separate. Yes, you can cross check it also. So for example, let's talk about the why it is happening. Let's talk about the this part. Let's say z1 is equal to a1 plus ib1 and z2 is equals to a2 plus ib2. Then corresponding z1 plus z2 is a1 plus a2 plus I times b1 plus b2. So corresponding z1 plus z2 conjugate is, we replace I with the minus I, so it is a1 plus a2, then it's a minus I b1 plus b2, and this is nothing but a1 minus I b1 plus a2 minus I b2, and this is z1 bar plus z2 bar. Okay, so this is how we can prove for the product also and division also. Okay, so you can, for example, we can prove for the z1 bar by z2 also. So okay, so one important thing, let's say z is equal to r e to the power I theta, so z bar is equal to r e to the power minus I theta. Okay, so let's say z1 upon z2, it is nothing but r1 e to the power I theta 1 upon r2 e to the power I theta 2. So this is r1 upon r2 e to the power I theta 1 minus theta 2. Okay, so what is z1 by z2 bar? So z1 by z2 bar, so it will be, I will replace by minus I. Okay, So it will be r1 by r2 e to the power the minus I theta 1 minus theta 2. So that will be we can say r1 e to the power minus I theta 1 and uh, divided by r2, this will be plus, so it will be e to the, so basically okay, one more step. So we can write like this: r1 upon r2 e to the power I theta 1 into e to the power I theta 2. So this is nothing but r1 e to the power minus I theta 1, and they will be r2 e to the power minus I theta. That's nothing but z1 bar upon z2 bar. Okay. So same way we can prove for the division also. Okay. ठीक है. So next, if we talk about the conjugate of multiple, let's say more than 2 z1, this is applicable for any complex number, but let's say for let's say it has 3 complex number as added, so the same as the z1 plus z2 plus z3. Okay, it is applicable for any, let's say z1 plus z2 plus z3 up to zn. If I take the conjugate, that is z1 plus z2 plus z3 up to zn, and that's why I can say that the if let's say z4, this one z, okay, same way I can say that the this is nothing but that means, okay, what I mean say that, see, we have discussed that z1 z2 z3 conjugate is equal to z1 z2 z3. So if they are all are equal, so I can say z1 or let's say z conjugate is equal to z. That means z cube conjugate is z conjugate cube. Okay, or in general I can say that z to the power n conjugate equal to conjugate of 1z to the power n. So basically we just need to have a power, we just need to have the there are n complex number multiplied, and corresponding conjugate of that is nothing but the conjugate of one complex number and they multiply n times. Okay, see, let's say I take example, if I want to find the conjugate, find let's say conjugate of, let's say z1 cube z2 minus z3 z4 z5 divided by, let's say z to the power 6 plus z7 square and let's say z8. Okay, so what is the conjugate? So the conjugate of this one, so let's say so the corresponding conjugate will be, so I can say that the corresponding conjugate, so let's say this complex number is, let's say this complex number is there. Okay, so let's say this corresponding complex number is w. So what is w bar or the conjugate? So conjugate will be individual. So I can say that this is Z1 cube Z2 minus Z3 conjugate, Z4 conjugate, Z5 conjugate divided by Z6 conjugate, okay, plus Z7 conjugate square, okay, then Z8 conjugate. Okay, so this is how we can find the conjugate. Okay, so for conjugate we just need to replace I with the minus I, that's all. Then you get the answer. And the beautiful things for the conjugate is that is very beautiful things for the conjugate is, if let's say complex number is z and the corresponding conjugate is added by 2, so by 2 they are nothing but the real part of z. Okay, you can check it. Let's say x minus iy plus x plus iy divided by 2, so this iy cancelled, I will get the x, that is the real part. Similarly z minus z bar divided by 2i will be the imaginary part of z. Okay, so z, so we can say that the z bar plus z is a pure real number, whereas z bar minus z is equal to is a pure imaginary. Okay, because we can check it why it is happening. So z bar minus, okay, it's a z, so why it is happening? So let's say x plus iy minus x minus iy, so obviously cancel and we get 2iy, which is a pure imaginary number. Okay, and one interesting thing is z square is nothing but z plus z bar. That is something we need to focus, used a lot in solving the problem. So you can check it. So let's say what is z bar, that is x plus iy into x minus iy, that is nothing but x square minus iy, that become x square y square, and that is mod z square. Okay, see, don't be confused. See, in vector we have the vector a square is a dot a, that is a dot product in vector. So something similar we can assume. Okay, this was something corresponding to the conjugate. Now let's talk about the modulus. Okay, so we discuss also, let's talk about the properties of modulus. Okay, we discuss the properties of modulus here. So if let's say z1 and z2 complex number, if take the modulus the same as the corresponding modulus. Okay, next we can say properties, if we divide z1 by z2, this is nothing but the z1 modulus upon z2 modulus, and the inequality, that is very interesting things. See, if we have any, let's say complex number z1 plus z2 modulus, this is always lower than the corresponding addition and always greater than the difference. So z1 difference z2. Okay, so we can prove this part and we can see basically what is happening here. So basically you should know that if let's say any let's say We'll prove analytically. So let's say we'll prove this one. Let's say Z1 proof of, let's say we'll prove first this one, Z1 by Z2 square is equal to Z1 by Z2 into Z1 by Z2 bar. Okay, that is nothing but Z1 by Z2 Z1 bar Z2 bar, and this is Z1 bar upon Z2 bar. This is nothing but mod Z1 square upon mod Z2 square. Okay, or we can say Z1 upon Z2 is nothing but modulus is nothing but mod Z1 upon mod Z2. Okay, now let's talk about this triangle inequality. Let's prove this part. This is interesting part. So let's say we have to prove this one. Z1 plus Z2 modulus is less than, let's say, Z1 plus Z2, and this is always greater than the corresponding mod Z1 minus mod Z2. So there are two ways we can say this. They are following the triangular inequality, or we can use analytical also. So that means, see, any triangle, we can say any triangle. Okay, any triangle. Let's say this is Z1, this is Z2, this is Z1 plus Z2, magnitude wise. We can't compare. Again, we discussed, we can't compare the since this is a modulus, that's why we can use the inequality. Otherwise complex number can't be compared. There is no inequality is not defined for a complex number. So we have this. So what does it mean? Third side is always lesser than the sum of two sides, and the third side is always greater than difference of two sides. So any side, let's say A, B, C. So obviously C is always C is always lesser than or equal to the third side, and always greater than the corresponding difference of two sides. Okay, this is simple triangle inequality. Okay, but let's say if we want to solve this analytically, we want to prove this analytically. So let's say we want to prove this particular things in let's say Z1 by the way good, Z1 minus Z2 is less than equal to Z1 plus Z2 is always greater than the lesser than the corresponding side. So let's prove it. We assume Z1 is equal to R1 e to the power I theta 1, or we can say mod Z1 e to the power I theta 1, and Z2 is mod Z2 e to the power I theta 2. Okay, so what is Z1 plus Z2? It's a R1 or let's say we make it Z1. So mod Z1 write in terms of trigonometric form. So cos theta 1 plus I sin theta 1 plus mod Z2 cos theta 2 plus I sin theta 2. Okay, now what is this? What is modulus? So let's say simplify it further, real and imaginary part. So mod Z1 cos theta 1 plus mod Z2 cos, these are the real part, cos theta plus I times mod Z1 sin theta 1 plus mod Z2 sin theta 2. So this is the z1 plus z2, and if we take the modulus, if we take the modulus, okay, square, that will what they will get a square. This is square plus this is square. So first of all, what is the modulus? Magnitude is, see, if we know that the magnitude of any, let's say any magnitude of z is a square plus b square, or z square is a square plus b square. Okay, same way here also, basically the square of the real part and square of the imaginary part. So it will be mod z1 cos theta 1 plus mod z2 cos theta 2 square, real part square plus imaginary part square, that is mod z1 sin theta 1 plus mod z2 sin theta 2 square. Square. Okay, so this is mod, in fact, a square. Here is a square. Now simplify. So z1 a square plus b square will simplify. We will get the mod z1 plus z2 square. If we simplify this part, so I will get z1 cos theta 1 plus z2 cos a square plus b square plus 2ab. Okay, so let's square it. So it will be mod z1 square cos square theta 1 plus, let's say, mod z2 square cos square theta 2 plus 2 mod z1 z2 cos theta 1 cos theta. This is the real part. Now squaring the imaginary part. So squaring this part, this is square also, so that will be same. So it will same, only thing is mod z1 square sin square theta 1 plus mod z2 square sin square theta 2 plus 2 times mod z1 mod z2 sin theta 1 plus sin multiply of sin theta 1 sin theta 2. Now this is mod z1 taking common, so cos square theta plus sin square theta is 1. So I will get mod z1 square plus mod z2 square. Okay, z1 square cos square theta 1 plus sin square, z2 square also cos square theta 2 plus sin square theta 2. So mod z2 square plus 2 z1 z2 in common. So I will get 2 mod z1 mod z2, then cos theta 1. So we'll get cos theta 1 cos theta 2 plus sin theta 1 sin theta 2. So that will be something like so this part. So I will get this part. Okay, this part. So basically this part, this one, this and this one. So they will be cos theta 1 minus theta 2. No? So I will say that this is nothing but mod z1 square plus mod z2 square plus 2 mod z1 z2 cos of theta 1 minus theta 2. Okay, so z1 plus z2 square is this one. Now we can say that if z1 plus z2 square, since it's z1, so its maximum value when the cos theta 1 minus theta 2 is 1. So for maximum value, its maximum occur when cos of theta 1 minus theta 2 maximum value is 1. So that will be mod z1 square plus mod z2 square plus 2 mod z1 mod z2. Okay, so this is nothing but mod z1 plus mod z2 square. Since they are all positive, no, there is nothing like plus minus. Mod z is always positive, so I can say that the z1 plus z2 is always lesser than mod z1 plus mod z2. Similarly, so basically I can say that the equality, and when does the equality hold? This equality hold when this cos theta 1 minus theta 2 is 1. That means cos of theta 1 minus theta 2 is 1, or we can say theta 1 minus theta 2 is theta 2 is 2 pi 4 pi, so 2 n pi, either 2 pi 4 pi 5 pi. And interesting thing, one more thing, see, we have uh, this one Kanga. So I copy it. So here, see, the minimum value, see, when the cos theta 1 minus theta 2 has a minimum value minus 1, okay, minimum value minus 1. So since minimum value, so I can say that the z1 plus z2 square has a minimum value. Minimum value means it's a greater than equal to z1 square plus z2 square minus 2 z1 z2. That is nothing but z1 minus mod z2 square. So taking the modulus both sides, so z1 plus z2 is always greater than corresponding z1 minus z2 modulo. Okay, and this equality holds. When does this equality hold? Equality holds whenever this cos of theta 1 minus theta 2 is equal to minus 1, or theta 1 minus theta 2 is odd multiple of pi by pi. Okay, so I can say it's a odd multiple of pi 3 pi, so it's a 2n plus 1 pi. Whenever with odd multiple of pi, this theta 1 minus theta 2 will be 1. And interesting thing, so when does this maximum or minimum occur? See, z1 plus z2 maxima occur z1 plus z2. This occur, we have discussed here, this occurs whenever the theta 1 minus theta 2 is 2 and pi, or we can say here also the argument of theta 1 minus theta 2 matlab argument of z1 upon z2 is 2 and pi. Okay, and this occurs when the argument of, so I can say here, so here this basically here equality occurs, equality holds when argument of z1 minus z1 divided by z2. See, because the theta 1 minus theta 2 is 2 and pi. Okay, theta 1 theta 2 means argument of, we have discussed the division, the argument of z1 by z2 is theta 1 minus theta 2, so that is the 2 and pi. Similarly, z1 plus z2 is always greater than the z1 minus z2. Okay, so this, in this case, the equality holds whenever the argument of z1 divided by z2 is odd multiple of pi. Okay, then say inequality hold. So one more interesting things about the geometrical meaning, we'll discuss the one very interesting geometrical meaning. One very important geometrical meaning. See, if we have any let's say eigenplane, and let's say we have the this z1 is the one complex number, and let's say z2, they're complex numbers, so obviously their modulus is z1 and this distance is z2. The corresponding z1 plus z2 will be somewhere here. Okay, we'll draw the parallelogram. Okay, so this is z1 plus z2, or let's say so basically this is z1 plus z2, or their modulo, or their modulus is, the distance is z1 z2. So this is z1 and this is z2. Can you see? This is z1, this is z2. So the sum of two sides z1 z2 is always greater than the third side. Okay, see, z1 plus z2 is nothing but the diagonal of parallelogram. Okay, we discussed in the previous lecture when we talk about the addition. So this is the diagonal of parallelogram formed by z1 and z2. Okay, okay, so this is the things we have discussed. Now let's discuss about the properties of so let's discuss about the property of the argument. Okay, see, if let's say z1 z2, what is the argument of z1 z2? It's nothing but the argument of z1 plus argument of z2. We can generalize it for n also. But interesting thing, principal argument, that is interesting things. What is the principal argument? So principal argument, I can say argument z1 z2 up to zn is equals to addition argument of z1 plus argument of z2 up to argument of zn plus 2k pi, where k is any integer. Why I am doing this one? Because see, principal argument means they should lie along 0 to pi. We can think of, see, let's prove it. So z1 z2 up to zn, it will be mod z1 e to the power I theta 1, mod z2 e to the power I theta 2 up to mod zn e to the power I theta n, and that is nothing but mod z1 mod z2 up to mod zn e to the power I theta 1 plus theta 2 up to theta n. So what is the, if we talk about the principal argument, so principal argument of z1 z2 zn is nothing but theta 1 plus theta 2 up to theta n. But the problem is, since principal argument, they should lie from minus pi to pi. Okay, which can only occur because, so minus pi to pi. Okay, now to make it lies to make this particular values, this particular theta 1 plus theta 2 lie between minus pi to pi, we have to add something. Okay, so we have to, basically in this case 2k pi is added. So 2k pi is added. Okay, such that is added, and k is such that this particular value, this theta 1 plus theta 2 up to theta n should lie between pi and minus pi. Okay, for example, let's take example. Let's say we have let's say z1 is equal to e to the power I let's say 2 pi by 3, and let's say z2 is e to the power I pi. So what is z1 z2? So argument of z1 z2, so the argument, let's say principal argument, so the principal argument of z1 z2 will be added to pi by 3 plus pi is added, but adding they will be, the value will be around what happened. So this is something 3 5 somewhere here, 2 pi by 3 pi minus pi by 3. So this is 2 pi by 3 and the pi is also added here. So after adding the pi, it goes here. So 2 pi by 3 plus pi. So this value will be around 2 pi minus pi by 3. Okay, that means total this value is 2 pi minus pi by that is this one, this value. This is 2 pi plus 2 pi by 3 plus pi. Essentially this is beyond minus pi to pi, so we have to add. So what I will do to make it like as a principal argument, we have to add something. So what I will do, I will, let's say, I will add minus 2 pi. Okay, here I will take k is equal to minus 1. Here I will take k is equal to minus 1. So taking k is equal to minus, now this particular value will lie along the will lie between the minus pi to pi. So now they have become the principal argument. Okay. Similarly for a division, let's talk about the division. So division means we talk about the principal argument. Same way, if I say the principal argument, that is argument z1 upon z2 will be anyway argument of z1 minus argument of z2 plus 2k pi. This k is added to adjust the values lies between minus pi to pi by 2. Okay. ठीक है. So let's take one example. Take a very basic example. Let's see, if someone asks you what is the argument of z1 z2 upon z3 z4 z5. So anyway we can always write like a log, they behave like a log. So argument of z1 plus argument of z2 minus argument of z3 minus argument of z4 minus argument of z5, but since they have to lie from minus pi to pi, we have to add 2k pi. Okay. Okay, let's do one example. Let's say argument of z is pi by 4 and z minus let's say z plus 3 minus I is equal to 4. Find the value of z. Okay, so how will solve? So z we don't know, some kind of complex number. So z, I can assume that the z is a plus bi. Okay, and since this is argument of z is pi by 4 and z is lying on a circle, so what does the z look like? See z, how does z look like? So what does this represent? This represent a circle. I can write like this. So let's write this thing. I can say it's a z. So this is z minus 3 plus I is equal to 4. that means that means there is a circle with center at minus 3 comma 1. Okay, minus 3 comma 1 is the center. So minus 3 comma 1, that means somewhere let's like this x, let's say this is something the axis. So its radius is given to be a 4. Now they are saying that argument of z is pi by 4. Z is pi by 4. How does this look like? They look like origin is there. This is, so this is angle is pi by 4. Okay. This argument is at pi by 4 and this circle is the intersection point. This is the intersection point. This is the solution. So so we have to find the intersection of the circle. By the way, I have not drawn it clearly. So if we clearly draw, we can easily get the thing. So let's say do it in a proper. Let's say do it in a proper manner. Okay, so proper manner. So let's say minus 3 plus is this. Okay, so minus 3, 1 2 3, minus 3 here and 1 here. So minus 3 comma 1 is the center and the radius is 4. So it will circle will somewhere lie 1. So it will be the, so let's say this is 1. So somewhere here the radius. So center is like this. So circle will be 1 minute. So this circle minus 1. Okay, so it will be here, it goes somewhere is the minus 3 and 1. So somewhere is the, so circle will somewhere is the 1. So it will be 4. Some approximate circle. Okay, center is here 4. This distance is 4 and this is somewhere is the origin, no? Because this is the origin. So now they are saying that the pi by 4. So this point center, this point is what, 1 comma 1, and since 1 comma 1, obviously the pi by 4 will be passes through this one. Got it? Because this distance 1, this distance 1, so this is corresponding, this is 1 and this also 1. Circle, because this is the center, this is the center of circle. So this is the diameter, this is the diameter. Okay, so this diameter, this is 4, so this distance is 1 and this also 1. So this passes through 1. So the where they are meeting point, so the z clearly from graph I can say is the 1 plus I. That is the answer. Okay.